Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
And what they detected a few times is they detected these bulks or waves of plasma, as we just kind of heard that blip on our screens.
Far beyond the planets, past the cold and empty regions where the sun's light is no more than a faint star, a lonely spacecraft drifted through the darkness. Voyager 1, humanity's farthest and most enduring emissary to the cosmos, had been silent for longer than anyone wanted to admit. Engineers had known this day would come, but when the signal finally arrived, the one that marked its last true transmission, it carried something that froze every breath in the room. It was not the slow fading of its systems that made this moment haunting. It was the nature of what Voyager 1 had detected, the thing that its final message conveyed before the darkness claimed it completely. Before we start, smash the like and subscribe buttons for more updates. Voyager 1 had been moving through interstellar space since it crossed the heliopause years earlier, a realm unshaped by the sun's solar wind, where only the raw tides of the galaxy swept through. For decades, its instruments had quietly recorded data, the density of plasma waves, the subtle shifts in cosmic ray counts, the whispers of magnetic fields stretched across light years. But then, in its last days of operation, there was a change, sudden, unexpected, and unlike anything seen in the decades-long mission. The readings began to show a distortion, a subtle warping in the background, cosmic signals that did not match any natural pattern in the archives. The spacecraft's magnetometer picked up fluctuations far stronger than the ambient galactic field should allow. These were pulses, rhythmic and precise, their intervals too deliberate to dismiss as coincidence. The data packets that carried this information took over 22 hours to travel back to Earth, each photon of the radio signal traversing a gulf of more than 15 billion miles. What returned was fragmented, as if something had interfered with the transmission en route, but enough came through to confirm that Voyager 1 had registered a highly unusual event in its immediate surroundings. The signal strength of the pulses increased as they neared, and the background cosmic ray density shifted in tandem with them, suggesting an interaction between the spacecraft's position and whatever was generating the anomaly. As the engineering team reviewed the transmission, their first instinct was to search for onboard error. Perhaps Voyager's ancient instruments were finally breaking down, producing false readings. Yet the more they examined the data, the less plausible that explanation became. Even with its advanced age, Voyager 1's systems had been remarkably stable, and the patterns in the transmission were too coherent to be dismissed as noise. This was not random degradation. It was an encounter, though with what, none could immediately say. The spacecraft's plasma wave instrument, designed to detect the density of charged particles, showed a sudden spike that held steady over several hours before tapering off. That steady state was accompanied by a secondary reading, a low-frequency oscillation deep within the range usually associated with planetary magnetospheres, but Voyager 1 was far from any planet. It was in a region where only the sparse atoms of interstellar gas should have been drifting. Something had altered that emptiness. As the last packets arrived, the pulses grew in frequency, the intervals tightening as if whatever was producing them was drawing closer. The magnetometer registered a sharp incline in field strength, so pronounced that it would have required a massive, localized source of magnetic energy, something orders of magnitude stronger than the faint galactic background. No natural astrophysical process matched the pattern exactly. The last fully intact packet contained data that suggested the source had shifted position relative to Voyager 1 at a speed impossible for any known celestial body. And then the stream ended. The final seconds of the final packet were distorted in a way no one could explain. The clean digital structure of the telemetry broke apart into chaotic bands of interference, as though the signal itself had been pulled through an unseen distortion before reaching the deep space network. Attempts to reconstruct those final moments yielded only partial frames, irregular bursts of radiation, a sudden collapse in the voltage of one of the spacecraft's main subsystems, and then silence. In mission control, that silence carried a weight that could not be measured in decibels. For those who had devoted their careers to this craft, Voyager 1 was more than metal and circuitry. It was a witness, an explorer, and a messenger from the farthest reaches. The realization that its last act was to send data that hinted at a structured, possibly artificial phenomenon in interstellar space was enough to send ripples of unease far beyond the scientific community. For decades, humanity had wondered what lay beyond the sun's protective bubble, what the galaxy would reveal once we stepped outside into true interstellar night. Voyager 1 had been the first to answer that question, returning a slow and steady stream of the ordinary mechanics of deep space. Yet here, at the edge of its operational life, it had broken that quiet with something profoundly different, something that did not fit the catalogs or models built from years of cosmic observation. The implications began to settle in like the cold of deep space itself. If the pulses were artificial, then they represented a source of technology older and more advanced than anything humanity could yet create, operating in a region no one had ever reached. If they were natural, they pointed to a physical process unlike anything currently understood, one that might exist only in the untouched expanses between stars. Either possibility forced a re-evaluation of the presumed emptiness of interstellar space. Voyager 1's trajectory had placed it on a path no human-made object could alter, a solitary journey into the dark forever. That meant the source of the pulses, whatever it was, had crossed that path by chance or design. Statistically, such an encounter in the immensity of space seemed vanishingly unlikely, unless the phenomenon was more common than anyone had realized, or unless it had been waiting. The thought of something waiting in the interstellar dark was not one the engineers voiced aloud, but it lingered behind every exchange of data reports and every attempt to reconstruct the final packet. The radio signal from Voyager 1 was already so faint that Earth's most sensitive antennas strained to capture it. If something had approached close enough to disrupt or consume that signal, it had done so within mere hundreds of kilometers of the craft, a scale that, in space terms, was intimate. Some specialists suggested gravitational lensing as a possible explanation for the strange distortion, but the symmetrical nature of the pulses contradicted that idea. Others looked to exotic astrophysical theories, invoking hypothetical phenomena like rogue magnetars or concentrated streams of dark matter. Yet the consistent structure of the signal refused to conform neatly to random astrophysical events. There was intent in the spacing, a precision that hinted at a message. No one could decode that message if it was one. The packets ended too soon, the interference too complete, but the fact that the distortion intensified in those final seconds suggested a proximity effect, as if the anomaly's interaction with Voyager 1 reached its peak right before the spacecraft's systems failed. Whether that failure was a byproduct of the encounter or a direct result of interference remained unresolved. What troubled some was the temporal alignment between the rising pulse frequency and the sudden loss of transmission. The two events occurred so close together that coincidence seemed less and less likely. If the source had targeted Voyager 1, then the termination of the signal might not have been a simple byproduct. It might have been the intent. The event reframed humanity's understanding of its position in the galaxy. Voyager 1 was not transmitting from some distant safety where the universe remained a passive backdrop. It was operating in an environment with unknown actors, forces, or phenomena, any of which might possess capabilities beyond our current comprehension. The spacecraft had ventured into a domain where the very assumptions of astrophysics could no longer be trusted without question. From a purely scientific perspective, the loss of Voyager 1 was expected. Its power supply, driven by radioisotope thermoelectric generators, had been declining for years. Eventually, the energy required to keep its instruments running and its transmitter active would fall below the threshold. But the nature of its final moments, the sudden spike in readings, the structured pulses, the interference, did not align with a simple fade into the dark. It was as if the universe had waited for the last chapter to write an entirely new kind of ending. The most compelling part of the data lay in the overlapping measurements from multiple instruments. The magnetometer's readings matched fluctuations seen in the plasma wave instrument, and both correlated with changes in the cosmic ray detector's counts. That meant the phenomenon was not confined to a single type of measurement or sensor error. It was a multifaceted physical event affecting different aspects of the local environment at once. Some pointed out that these overlapping signatures suggested a dynamic field, possibly generated by a massive moving object. But the velocity implied by the frequency shift would have been extreme, exceeding the relative speeds of any known starship or natural interstellar body. And if such an object existed, its detection by Voyager 1 marked humanity's first direct observation of it. The mission scientists could only model scenarios with the limited data they had. Most of those scenarios led to the same sobering realization. Whatever caused this encounter, Earth had no way to reach it, study it further, or avoid it should it ever come closer to our own system. Voyager 1 had been the perfect sentinel, alone, silent, patient, and it had stumbled into something for which there was no precedent. Even without the capacity for photographs or high-resolution imagery at this stage of its life, Voyager 1 had managed to convey an encounter in the language of physics and electromagnetic patterns. It had, in essence, spoken its last words through the universal grammar of numbers and waveforms. That message now sat preserved, its every fluctuation and anomaly pored over by minds searching for meaning in its patterns. Long before this moment, Voyager 1 had already changed humanity's place in the cosmos by showing the pale blue dot suspended in the void. But its last act went further. It hinted at a presence in that void. Whether that presence was an ancient traveler, a wandering relic, or a natural engine of the galaxy itself, the fact remained that we had not been as alone in the interstellar night as we had once believed. In the weeks leading up to that final transmission, Voyager 1's journey had been quiet, almost uneventful. It had drifted through a corridor of space where the particle density was lower than average, its instruments running on carefully rationed power. The suddenness of the anomaly's arrival was, in that sense, a break in a long monotony, a signal in a silence that had stretched for years. That signal, though fleeting, had been enough to upend decades of certainty about what awaited beyond the heliopause. Voyager 1's final transmission was not a gradual fade into static. It was a crescendo, an escalation of readings and signals culminating in a singular moment where the universe reached back. It was an ending that no one had written into the mission plans, and yet one that now seemed almost inevitable. As if the very act of sending a human-made object into interstellar space had always carried the risk of an answer. That answer came in the form of pulses across the dark, a final surge of information that defied easy categorization. It was a transmission that carried with it the weight of possibility. The possibility that our galaxy holds far more complexity, far more mystery, and perhaps far more company than we have dared to acknowledge. And with the silence that followed, the vastness beyond the sun felt both larger and closer than it ever had before. The hours after the final signal from Voyager 1 reached Earth were unlike anything in the mission's long history. The Deep Space Network antennas had been tracking the craft faithfully for decades, their massive dishes angled precisely to capture every faint whisper from the void. Now, instead of the familiar steady telemetry stream, the consoles displayed only an empty line. There were no error codes, no recovery beacons, no confirmation packets, just silence. In that silence, the weight of the transmission's contents deepened. The data Voyager had sent was not simply a collection of anomalous readings. It was a tapestry of interwoven signals that spoke of interaction, of cause and effect, of something altering the immediate space around the spacecraft in ways that should have been impossible at such distances from any significant mass or energy source. It wasn't the kind of randomness that cosmic radiation occasionally produced. It was structured, deliberate in its pattern. Specialists began to run deep spectrum analyses on the magnetic and plasma wave data. They isolated the rhythmic pulses Voyager had detected and compared them against the library of known astrophysical sources, pulsars, fast radio bursts, interstellar scintillation effects. None of them matched. Pulsars, while precise, emitted in bands that were both regular and wide in scale. Fast radio bursts, on the other hand, were sharp, transient, and seemingly chaotic in their distribution. The pulses Voyager had encountered were neither. They existed in a steady temporal rhythm, gradually increasing in frequency over a measurable interval. This alone was an anomaly worth noting. But it was the way they shifted, narrowing their intervals as though drawing closer, that sparked the most unease. One of the suspicions was that Voyager had passed through the path of some form of localized particle jet. Perhaps a focused beam of charged particles from an unseen stellar remnant. But even the densest known jets, those emitted by neutron stars or black holes, could not produce the magnetometer fluctuations Voyager had recorded without also destroying the craft outright. What the data showed instead was more akin to controlled interference, like the way a radar signal might sweep over a passing object, steadily locking onto it as it closes distance. That implication, control, was one that the more cautious members of the team avoided stating aloud. The scientific method demanded natural explanations first, but every hypothesis based on standard astrophysics collapsed when compared to the precise timing of the event. If this was a natural source, it was one unlike anything ever observed, and it was moving in a way that defied the expected randomness of cosmic processes. Engineers examined the final seconds of the data stream with obsessive care. In the telemetry, they found an abrupt drop in the main bus voltage just moments before the transmission ended. Normally, a voltage drop on Voyager could be explained by a power-hungry instrument switching on or a temporary fault in the thermoelectric generator. But here, the drop coincided exactly with the peak of the incoming pulses. In the final fragment of coherent data, the magnetometer spike and the voltage collapse were synchronous, almost as if the external field had directly interfered with the spacecraft's electronics. There was something else, something subtler, that emerged from deeper analysis. In the moments before contact was lost, the low-gain antenna recorded a faint residual oscillation that did not match any internal system frequency. This oscillation was embedded in the carrier wave itself, almost like an echo layered onto Voyager's outgoing signal. While the main high-gain transmission was distorted beyond recognition in the final moments, this faint oscillation persisted for a fraction of a second after the main signal had vanished, as though something else, separate from Voyager's own systems, was continuing to transmit. The scale of what that implied was staggering. For an oscillation to appear on the outgoing carrier, some external influence had to be close enough and precise enough to alter the electromagnetic signature in real time. At Voyager's location, 15 billion miles from Earth, this could only mean that the source was effectively in the spacecraft's immediate vicinity. Even if the anomaly were a natural occurrence, its physical proximity suggested that the interstellar medium was not as uniform and uneventful as many had assumed. There could be regions, pockets, corridors, or filaments where unknown forces shaped the environment on small scales, perhaps relics of ancient astrophysical events. The data hinted at a density fluctuation in the surrounding plasma, but the change was far too sudden and localized to match any known process of galactic turbulence. As the investigation unfolded, a broader realization began to emerge. Voyager 1's trajectory had taken it into territory entirely beyond the predictive reach of Earth-based observation. The spacecraft's path had been plotted decades earlier with only the broadest knowledge of what lay beyond the heliopause. Its course was unalterable, its speed fixed. Whatever it encountered now, it did so not by choice but by inevitability. The possibility that the pulses were part of a structured signal led to heated discussions about their origin. A signal implies a sender, and a sender implies intent. If the source was capable of emitting precise magnetic or electromagnetic pulses across interstellar distances, it was operating on an energy scale orders of magnitude greater than anything humanity could achieve. The deliberate nature of the frequency increase suggested tracking, awareness, something responding dynamically to the presence of Voyager. Some speculated about the nature of the space between stars in ways that had previously been confined to the fringes of astrophysics. Perhaps the void contained artifacts, objects drifting through the galaxy for millions of years, relics of civilizations long vanished. Such objects might be dormant until triggered by the approach of a passing body, awakening only to register, analyze, and perhaps neutralize it. Others wondered if the pulses were not communication at all, but rather a byproduct of a technology designed for some other purpose. They could have been navigational markers, energy transfers, or containment fields completely indifferent to Voyager's intrusion, yet still capable of overwhelming its delicate systems. If this was the case, then Voyager had not been targeted so much as it had stumbled into a region of activity it was never meant to traverse. As the hours turned into days, the data took on a different kind of significance. The spacecraft's journey had been a slow march away from everything familiar. and now its final act had delivered not closure but an opening into a deeper unknown. The sheer improbability of such an encounter raised uncomfortable questions. The galaxy is vast, and the density of objects, especially in the interstellar medium, is astonishingly low. For Voyager to have met such a phenomenon by chance suggested either extraordinary coincidence or that such phenomena were far more common than previously thought. If they were common, then the boundaries of human exploration were far more dangerous than imagined. Interstellar space, often thought of as a silent expanse, might instead be an environment threaded with active regions, each governed by forces and entities beyond current human understanding. In that context, Voyager's encounter could be seen not as an isolated incident, but as an early warning. The mission logs for that day became historical records in themselves. Every keystroke, every time-stamped reaction from the monitoring teams was preserved. The mood in the control room shifted from analytical detachment to a quiet, almost reverent recognition that they had been present at a moment no one had truly expected. The moment when a human-made object in the farthest reaches of the galaxy ever touched by our technology had sent back a signal that challenged the most basic assumptions about what was out there. In the following weeks, scientists began mapping the possible location of the anomaly relative to Voyager's path. Using the timing of the pulses and the subtle Doppler shift in the signal, they constructed models of how fast and in what direction the source might have been moving. The results were unsettling. The modeled velocities were too high for any known natural body, and the movement appeared to be a deliberate vector change rather than a gravitational slingshot or random drift. The acceleration implied by the data defied the limits imposed by conventional propulsion physics. In the interstellar void, without a medium to push against, any form of acceleration would require massive energy expenditure, unless the source was employing a method of movement completely outside human experience. This alone hinted at a technological origin, whether from an advanced civilization or some autonomous construct designed for purposes unknown. Attention turned to the narrowband interference patterns found in the final milliseconds of the last packet. They were unlike cosmic noise, more like the harmonic distortion produced when multiple signals overlap and interfere. The overlapping frequencies were so finely spaced that they seemed engineered, as though the source was operating multiple transmission channels simultaneously. The precision of these frequencies suggested an internal synchronization mechanism, not the random alignment of natural events. In one possible interpretation, the interference could have been an attempt to mimic Voyager's own carrier wave, perhaps to establish a handshake protocol or overwrite its outgoing signal. If that was the case, then the source had not simply been passively emitting, it had been actively engaging with the spacecraft's communication systems. Such a possibility was as alarming as it was fascinating. The image of a silent object in the interstellar dark, locking onto Voyager's signal and reshaping it before cutting it off entirely, was one that stuck in the minds of everyone involved. It reframed the encounter from a passive anomaly to an interaction, one whose outcome had been the complete removal of Voyager's voice from the cosmos. The lack of aftermath only amplified the tension. There was no follow-up signal, no echo from the void, no hint that Voyager still existed. In that sudden silence lay the stark reality of deep space. Once contact was gone, the craft became a ghost, moving forever through a region from which no further information could return. All that was left was the final data set, its numbers and waveforms the only remaining testament to what had happened. While much of the public might think of space as empty, devoid of interaction, the people studying Voyager's final moments knew better now. The encounter suggested a galaxy rich in activity, much of it invisible to Earth's telescopes and instruments until one of our emissaries stumbled directly into its reach. If the same thing awaited other missions venturing beyond the heliopause, then humanity's steps into the interstellar arena were already under observation, or worse, under assessment. The thought of assessment was difficult to shake. If the source was capable of detecting, tracking, and interfering with Voyager's transmission, it might also have been capable of identifying its origin. The craft carried information about Earth, engraved on its golden record, stored in its transmissions, embedded in the very structure of its engineering. To the unknown, Voyager was both a messenger and a map. The quiet realization that this information was now, perhaps, in the hands of something beyond human understanding was the unspoken undercurrent in every meeting, every review session. The scientists and engineers could analyze the data endlessly, but the truth of what had intercepted Voyager and why would remain suspended in that unreachable region of space, beyond follow-up, beyond confirmation. Voyager 1's final signal was not the slow fade of a machine reaching its natural end. It was the sudden eclipse of a voice in the dark, cut off at the height of an anomaly that seemed to close in deliberately. The sheer precision of the encounter, the improbability of its timing, and the structured nature of the signals combined to leave one lingering impression that the craft's long journey had not ended by chance, but by contact. And somewhere, far beyond the sun's light, the object or phenomenon that ended that journey continued on, unseen, untraceable, carrying with it the last unspoken truths Voyager had gathered before its silence. In the weeks that followed, the Mission Data Analysis Center became a kind of shrine to the last hours of Voyager 1. Walls that had once been covered in generic mission charts now displayed enlarged waveform plots, magnetic flux variations, and the peculiar plasma density graphs from the final minutes of transmission. The last dataset had been broken into segments so small that even microsecond variations could be examined individually. It was no longer about operational troubleshooting. It had become an act of decoding, as though every anomaly might hold a hidden layer waiting to be unlocked. One of the more perplexing discoveries came when cross-referencing the plasma wave data with the deep background cosmic ray counts. In the seconds leading up to the abrupt cutoff, cosmic ray levels dipped unexpectedly. This wasn't a gradual shielding effect, as would be expected from a natural density increase in surrounding particles. Instead, the drop was abrupt, synchronized with the pulse patterns Voyager had detected. It was as if some form of electromagnetic envelope or field had wrapped around the spacecraft, reducing the influx of high-energy particles. The shielding effect carried unsettling implications. Such a phenomenon would require precise energy control and deliberate spatial targeting. While a planet's magnetosphere could shield in this way, Voyager was nowhere near any planetary body. If the source was capable of generating such a localized protective or perhaps isolating field, it suggested advanced manipulation of the surrounding medium. In more speculative corners of the discussion, some scientists began to wonder whether the anomaly's action had been defensive, as if Voyager's presence had triggered a protocol designed to quarantine it from the surrounding environment. This theory gained traction when another pattern emerged. A subtle phase shift in the pulses just before the final spike. The rhythm altered by a fraction of a second, an almost imperceptible change unless the timestamps were analyzed at the highest resolution. That shift could have been meaningless noise, but if interpreted as a response, it might represent the point where the source altered its activity in reaction to Voyager's own systems. Attention turned briefly to Voyager's power distribution logs. Just before the drop in main bus voltage, the craft had automatically cycled one of its smaller science instruments into a low power mode. This was a standard procedure, triggered by the onboard computer to conserve dwindling energy. But the timing was uncanny. Seconds later, the external pulses began to tighten in frequency. Was the source reacting to a change in Voyager's emissions profile? If so, the interaction was not simply passive observation, it was adaptive. The source appeared to have monitored Voyager's output closely enough to register internal operational changes, then adjusted its own activity accordingly. Such behavior implied sensing capabilities far more sensitive than anything humanity had ever deployed in interstellar space. The engineering team attempted simulations to see what Voyager's final seconds might have looked like from its own perspective. Using the last complete readings, they created a virtual reconstruction of the surrounding plasma environment. In the simulation, the incoming pulses appeared as concentric magnetic ripples, each one slightly stronger than the last, converging on the spacecraft. At the moment of the final spike, the simulated space around Voyager warped, an effect not caused by gravity, but by an intense and focused electromagnetic distortion. The reconstruction did not definitively explain the event, but it provided a visual context that left even the most skeptical team members unsettled. In the model, Voyager was not just drifting into random interference, it was being enclosed. The field around it tightened in synchrony with the pulses until, at the last measurable instant, the craft's transmission line dropped to zero. What made this more disturbing was the nature of the electromagnetic distortion itself. It had a profile unlike stellar wind interactions or shock fronts from supernova remnants. Instead of a chaotic wave pattern, it was precise and layered, suggesting a stable generator of some sort. Yet, whatever the generator was, it left no trace in Earth-based telescopic surveys. Even after focusing deep field instruments along Voyager's last known trajectory, astronomers found nothing. No optical signature, no radio beacon, no residual emissions in the wavelengths they could detect. This absence of detectable evidence led to another hypothesis. The source might not be emitting in the bands humanity knows how to observe, or it could be actively concealing its presence. Concealment in the vacuum of interstellar space is no simple matter, which again raised the question of whether this was the work of a natural anomaly or something far more advanced. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Voyager 1's final message? What do you expect next? We want to hear from you. Thank you for watching, and see you next time.